Hello everyone, welcome to my technical seminar session. I am Bhumika.j.m, studying in Department of ISC from Sri Venkateswara College of Engineering under the guidance of Marian Naveen sir. Today's my technical topic is machine learned cloud classes from satellite data for process oriented climate model evaluation. These are the some of the contents which I am going to complete in this seminar. Let's go for introduction. Cloud classes are something which is used to classify different type of clouds. Classification is done under texture and height via machine learning using satellite data. Climate models are quantitative methods to stimulate the interactions of the important drive. Let us know some of the keywords in this paper. ESM is a Earth system model which gives critical information. MODIS is a moderate resolution imaging spectroradiometer. ESACCI is a climate change initiative. CloudSat is a satellite used to analyze. This tool particularly useful for studying and analyze to get potential error-free information, helps in agriculture activities and weather forecast. Let's go for literature survey. Evaluation of cloud, radiation and precipitation in CMIP6 model using global weather status derived from ISCCPH cloud property data. The study uses high quality ISCCPH cloud property data, which is widely accepted as a benchmark dataset for evaluating climate model. This enhances the reliability of study finding. And the cons of this paper is the study focus only on the evaluation of cloud, radiation, and precipitation of CMIP6 model. Let's come to the second paper. Machine learning of cloud type shows higher climate sensitivity is associated with low cloud biases. The use of satellite data to train the machine learning model allows for a more comprehensive and global analysis of cloud type as compared to traditional ground basis measurement. And the cons of this paper is that the study is based on observational data and it is difficult to establish causation between cloud type, climate sensitivity, and cloud biases. Cloud CCI Advanced Very High Resolution Radiometer Post-Meridian dataset version. Dataset is freely available to the research community, which promotes collaboration and enables research to build on each other's work. The AVHRR PM dataset only covers 35 years of data. While this is long-term period, it may not be sufficient for some long-term climate studies. So this is the con of the paper. So let us go for the next slide. In this fourth paper, combining crowdsourcing and deep learning to explore the mesoscale organization of shallow conversation. The pros of this paper is that the combination of crowdsourced data and deep learning technique leads to high accuracy result. And the cons of this paper is that accuracy and consistency of crowdsourced data may be influenced by the quality of the crowdsourced data and the level of expertise of the participants. Fifth paper is climate goal and computing the future of clouds. And the pros of this paper is provides a basis for informed decision making regarding climate policies and mitigation efforts. And cons of this paper is it does not provide a comprehensive overview of all the factors that contributes to climate change and its impact. And the sixth paper in this literature survey is assessment of CMIP6 cloud fraction and comparison with the satellite observation. And the pros of this paper is the study highlights the differences in cloud fraction among the model and identifies the model that performs better in stimulating cloud fraction. And the cons of this paper is the study does not expose the causes of the discrepancies between the simulated and observed cloud fractions. So now let us study working and implementation of this process. Satellite data products work is based on data from three satellite products. And these three satellite products are CloudSat, MODIS, and ESA Cloud CCI. CloudSat. Cloud classes uses in the Cumulo dataset are obtained from this CloudSat. Radar measurements are taken from the CloudSat. What is this radar measurement? Radars are nothing but a radio detection and ranging measurement is a process of measuring direction, altitude, range, and speed of the distant object. And leader detection is a light detection and ranging detection data are collected from aircraft using sensors that detects the reflection of the pulse laser beam. This LiDAR data are obtained from the cloud aerosol LiDAR with orthogonal polarization. This information is used as a basis for the logic cloud classifiers and labeling of multiple clouds along with the help of grid cells. MODIS, MODIS, which is also called as Moderate Resolution Imaging Spectroradiometer. This is a satellite-based sensors used for Earth climate measurement. This MODIS cloud product data includes 9 pixel level. This provides 1354 into 2030 kilometer square pixel cover. ESA Cloud CCI. This is basically generating long-term and coherent. Coherent is nothing but logical and consistent cloud property dataset, which is something called observational instrument. IRIS-Net, invertible residual network, which is used to train. This training is termed semi-supervised for both labeled and unlabeled samples. IRIS-Net is applied to tiles, which is 3 into 3 of MODIS pixels to determine the cloud type of central pixel. By this, it will predict the whole tiles. To train this IRIS-Net, it uses the physical variables as a features. So, basically, labels and features are converted as a pixels. These pixels are considered as a tiles. When a grid is applied to the image, the vertical and the horizontal grid makes the image into a small pieces called tiles. Then, understanding the majority properties of these tiles, by this process, and data is normalized, and then by using CNN, which is used to train. Now, let's go for next slide. By this classification, it helps to label the images. In this slide, regression is the second stage of machine learning. In this process, training data, which is less developed state, are trained using random forest. By this process, cloud statistics are considered as result of regression. Features of any image per pixel value along with grid cell averages and pixel labels from IRIS-Net are then classified. To learn to predict relative features of each cloud type by analyzing every grid cells by using algorithm called random forest. Then this process classifies the image predicted cloud type fraction. So with the help of this random forest algorithm, which helps to predict the grid cells average and per pixel values of the image, and even the per pixel value from IrisNet. Basically, it helps to learn, predict relative features of each cloud type per grid cells. So let's go for third step, which is called validation. We use this validation step to demonstrate how this technique generalized to coarse grain gathered from various sources and also collects other data set. Coarse grained ESA CCI data consist of cloud fraction, predicted fraction, prediction accuracy, regional pattern, temporal cycles, physical consistency, and etc. Validation is a process of applying the trained regression model to data that it has never seen before, which helps to verify the methodology. The physical consistency of the forecast is then examined. Let's go for the next slide. In this slide, we are going to study about cloud type evaluation. The same information what we studied in few last slides with the same information in the single diagram, which is a flow diagram of the whole concept called cloud type evaluation. So in this process, there are three main parts: machine learning, processing, and data sets. So at first, cloud sat and modus informations. The purpose of the cloud sat is cloud type. It gives information about the cloud type. And modus is the physical variables. Gives information about the physical variables. Cumulo data sets. Basically, a cumulo data sets is a information or a benchmark data set for training and evaluating global cloud classification model. These informations were aligned. After annealing, these informations were sent to training. These training informations were sent for IrisNet. Where this IrisNet we studied in the classification process, which is the first step of the machine learning. After making machine to understand what kind of information is came from the different data source, this information were sent to the cumulo data set. What this cumulo data set is labeled one. Before, for the first cumulo data set was unlabeled, which is the new information, and this one is that new informations were made as a label, and this information, labeled information, were sent to the cumulo data set. After that, these cumulo data set were sent to the coarse graining. What is this coarse graining? Basically, coarse graining is a process of training the data, and which is less developed state are trained using the random forest. By this process, cloud statistics are results of regression. After this information were sent to the RF. RF, we all know that it is a random forest. Random forest is used on unobserved data to validate the effectiveness of the techniques and access the target data. So at this point, we are going to get a clear information about what kind of picture is we got. And RF is the second stage of the machine learning. And ESACCI cloud, which is the one of the third process, then the purpose of this is the physical validation and variables. Means it consists of physical variables and even a validation process. After that, coarse graining information, collect the information and apply it to the RF. By this, with the help of this RF, they are going to get the proper information about what kind of image we got. In this slide, we are going to study about cloud types which are used in cumulo dataset. Circus, altostatus, altocumulus, status, stratocumulus, cumulus, nimbostatus, and deep convention. Physical variables are cloud water path, cloud optical thickness, cloud top pressure, cloud top height, cloud top temperature, surface temperature, effective cloud particle radius, effective emissivity, cloud thermodynamical phase. Because of this information, we are going to get, and the machine is going to give a proper, accurate information about the cloud which are present or which are photo or a pics were taken from the sensors. Let's go for next slide. In this slide, we are going to study about future enhancement. In this process, it is difficult to sense what kind of clouds are present at night time. It required special research so that image can be taken at dark night. Sometimes smoke due to forest fire are appeared like clouds. Sensors should sense by considering different criteria to give required results. In this slide, we are going to study about conclusion. The study aims to use machine learning algorithm to analyze cloud classes derived from satellite data for the purpose of evaluating process-oriented climate model. If the study found promising result, it could potentially lead to improved climate modeling and better understanding of the Earth climate system. The success of the study would depend on several factors, such as quality and quantity of the satellite data used, the accuracy and effectiveness of the machine learning algorithm employed, and the ability to effectively integrate the result into existing climate model. Overall, the conclusion of the study would depend on specific result obtained and the success of the methodology used. And these are some of the reference papers which I studied. And thank you everyone for your time, and thank you for watching my video.